Hi all, so today we're going to be looking at more standard integrals. After the previous video we looked at a lot of the rules which are on our formula sheet. So starting off, we are remembering what we've done with differentiation, and we had the first rule where showing if you differentiated the inverse sine function, we got 1 over the square root 1 minus x squared. Okay, so that was a new thing from this year. It's on your formula sheet also. But obviously, because we can now differentiate that, we can then get back and do integration. Okay, so the general rule, or sorry, I should say the initial rule that leads from that is this first rule here. Okay, so integral of 1 over square root 1 minus x squared will have to give me back the inverse sine function plus our constant c. We always get that constant when we integrate without limits. Okay. However, the general rule, okay, the one that is on your formula sheet is this one here. Okay, when you're not always going to have it as nice as just 1 minus x squared in the square root, you could have another function squared minus x squared, and therefore we get x over a inside our sine inverse function plus c. Okay, so that's the rule we're going to look at first today. So look at a couple of examples. So the first example, okay, we want to integrate the integral 1 over square root 9 minus x squared with respect to x. Okay, so we can see it's not quite in the very first form, okay, but it's definitely in the second form, and I've got the square root of 9 minus x squared, which is like the square root of a squared minus x squared. So the rule's going to be here, we'll get sine inverse x. Now my a value is going to be 3, because 3 squared will give me 9. So I get the sine inverse of x over 3 plus c. Okay, so just simply use my rule, noticing that my a value there had to be the value 3. Okay, so that's the first example. Look at the second one. You'll see they work very, very similar. We get the square root, 1 over the square root 4 minus x squared dx. Okay, so that's dx. And, okay, similar idea, we're going to get the sine inverse function. But this time my a value would have to be 2, because 2 squared would have to give me 4. So I get sine inverse x over 2 plus my constant c. Okay, so that's the first rule there, where I get sine inverse. Now if you actually have a look at your formula sheet, we're going to look at the one that gives us the tan inverse. However, when we done differentiation, there was a rule for cos inverse as well. When we had to differentiate cos inverse, we got an answer when we differentiated it. If you actually look at your formula sheet very closely, if you differentiate sine inverse and differentiate cos inverse, the only difference really is a negative. Okay, so that's why when you integrate functions like this, we can just write it all as sines. Okay, you just have either negative sign or positive sign, depending on if there's a negative to start with in the function. Okay, so that's why there's not one for cos inverse. Okay, let's have a look at the general one to get tan inverse back. Okay, so remember, if we differentiate tan inverse, that was the one that became plus, but it had no square root. So this is the general form we've got here. Again, if we don't have a 1 plus x squared, it could be a squared plus x squared. We've got this rule here. And just note that we have the 1 over a part as well, okay, at the front. Okay, we need to make a fraction with that at the front of our answer. So let's look at the first example here. So we'll call example 3. It's going to be the integral of 1 over, and we'll look at 9 plus x squared with respect to x. Okay, so that's what I've got there. So again, a bit like the last time, we can hopefully see that the value for a would be 3. Okay, 3 squared would give me 9. So therefore, it's going to be 1 over 3 at the front this time. Tan inverse x over 3 plus c. Okay, so we've got that there, and that would be my final answer for that one. Okay, so again, hopefully you can see now the rule is nice and straightforward to carry out. There is sometimes where you have to fix your function first. Okay, so if we actually look at this example here, and I'll ask we'll look at example 4. If I've got 1 over x squared plus 4x plus 13 with respect to x. Okay, I want to integrate that there. Now, this is where we have to try and get it into the form we can use it. Okay, so I've got no square roots, so I know it's going to be a tan inverse question when it leads to it, but I need to write it in terms of two things squared, okay, or at least a squared x value here. So I need to complete the square for my denominator. Okay, so you complete the square, National 5 skill. I'm doing it for x squared plus 4x plus 13. Okay, so if I complete the square, there's loads of ways you can do it. You can equate coefficients. Okay, you can just do the rule, half square, subtract. Whatever way, as long as you know how to do it, you would get x plus 2 all squared. You would then have plus 13 and then subtract the 4 that you would get from having 2 squared. So therefore your final answer would be x plus 2 all squared plus 9. Okay, so that's what complete square. So I can rewrite my question. It's 1 over x plus 2 all squared plus 9. So again, if I equate it back to the original formula, I've got x plus 2 instead of x just all squared, so that's going to go in the tan inverse function there. My a value would still be 3 because 3 squared would give me 9, so I'm going to get 1 over 3 tan inverse. It wasn't just x, it was x plus 2 all divided by 3 plus c. Okay, there's a few examples of both rules that I'm going to ask you to have a go at today. Okay.